Hello and welcome, ladies and gentlemen, to the third Hazeltest video. It's great that you're all here because today we're going to talk. Just sort of love that these effects happen. Yeah, good job. Whoever thought of this, awesome. So anyway, welcome to the third video, and today we're going to talk about a feature that was briefly used and very briefly shown in the first two videos, that being the map load runner. So the title of today's video is Let There Be Load, Part 1, an introduction to the map load runner. That being a hint, of course, that there will be a part 2, and actually there will also be a part 3, because we can't, cram all of it into one video, because, in today's busy times, no one watches a 90-minute video anymore. So, let's get started with the set of slides that I brought along this time in order to sort of, guide us through the content of this video. So there's two new things here going on in this video. The first one being those slides. The first two videos did not have slides. This time around, I'm using them for, as I said, additional structure. And the second one, as you may have noticed, this time my head is encircled rather than being in a rectangle kind of thing that I used in the previous videos, in order not to cover, as much of the content as the previous rectangle did. However, the problem with a circle, of course, is that it would probably bother you greatly if there was a circle and the head, like the central piece of content in that circle, was misaligned, was not perfectly in the center. So, like this, or like this. So it would bother me greatly anyway, so I'm trying, my best to sort of keep my head centered in the middle of the circle. So, let's see how that goes. So, Let There Be Load, Part 1, an introduction to the map load runner. And this is the structure for today. We'll talk about load dimensions first. This is sort of it's a recap on one hand, and also an introduction of a little bit of new material, because as it turns out, the 5 load dimensions that we talked about and that we introduced in the first two videos are insufficient in order to talk about the map load runner. So we're going to need a 6th one. And the second point for today is I'm going to take you onto a little trip down memory lane in scope of, a little bit of Hazeltest history, really, and introduce you to the map Pokedex Runner very shortly, because the map load runner is sort of an extension of the map Pokedex Runner. The map Pokedex Runner was the predecessor and had 2 drawbacks, really, and the map load runner was like the next logical step that simply, had to happen in the application. So, without any further ado, let's get started on load dimensions. Let's do a very short recap first. Why do we need those load dimensions? Because it's kind of an abstract term, isn't it? So, load dimensions are important to classify and quantify what load means to a Hazeltest cluster, and in terms of the test tool that's creating the load. Think of it like this. If you have 10 GBs of data stored in Hazeltest cluster A, and then 10 GBs in Hazeltest cluster B, but in Hazeltest cluster A, all of the data was stored in one map, whereas in cluster B it's scattered across 10,000 maps, then the load patterns, or the usage patterns that these two clusters will exhibit, will be very, very different, despite the fact that they both store 10 GBs of data. That's a very, very simple example to show that we need ways to quantify and classify what load means to a Hazeltest cluster, or else it's very, very difficult to reason about the load that a Hazeltest cluster is currently exposed to, or the load that a test tool such as Hazeltest creates, right? In the previous videos, we established and indeed worked with 5 load dimensions. The first being the number of items, the second being the item size, 1 and 2 obviously making up the total, memory consumption that the cluster is currently exposed to. Third, number of data structures. Fourth, the number of clients. And fifth, that was kind of a meta dimension. Well, I called it a meta dimension because I think it is. The 5th load dimension is the cluster health. short example, what I mean with meta dimension. For example, when a Hazeltest member crashes, think of it like you screwed up some memory configuration, right? And the JVM crashes due to an out-of-memory error. Then if the member goes down, then the remaining members in the cluster will have to do a little bit of housekeeping work in order to reconcile themselves. For example, in case there are partitioned data structures, such as maps, and there probably will be, then the remaining members have to repartition, all the data. And that will create additional load on those members. That's why it's a meta dimension. Usually it's like, that's not something that the typical Hazeltest client, unless it is, a malicious client wishing to destroy things, will cause on a Hazeltest cluster. Whereas the first 4 are really direct results of client interactions, hence, the term meta dimension. So the problem with those 5 load dimensions is that they are insufficient to fully describe the meaning and the impact of load. In fact, it's really simple to come up with a scenario in which those 5 load dimensions are exactly identical on 2 Hazeltest clusters, cluster A and B, and yet B behaves, very, very differently. For example, exhibits higher response times because some other load dimension is creating additional load on that cluster B, right? So we definitely need additional load dimensions to classify and quantify load. And for the purpose of talking about the map load runner, the introduction of a load dimension 6 will be sufficient. Probably as time passes and as more features are added to Hazeltest, it will be necessary to introduce yet further load dimensions, but again, for the purpose and the context of the map load runner, introducing a 6th load dimension for the operations per second is sufficient. So, short example for describing load in terms of those 6 load dimensions. Load dimension number 1, the number of items, right? The cluster holds 1 million items. Each item is 100 kilobytes, for example. That would be, if you assume that there's no backups for your 1 million items, that would give you about 100 GBs of occupied memory. It would be very weird to have no backups for 1 million items, but, for the sake of simplicity, let's just roll with that. Load dimension number 3, the number of data structures. The items are held in 5,000 maps in total. Load dimension number 4, the number of clients. Those maps are acted on by 120 clients. And then load dimension 5, the meta dimension, is that, the cluster is healthy in this case, so there is no additional stress on the members. And then said, newly introduced load dimension number 6. So that circle is very small to show things, actually, I'm just noticing. So load dimension number 6, all 120 clients accumulate around 500 sets per second across all maps. So we will revisit these 6 load dimensions both today and in the upcoming videos. So with that short recap and the introduction of load dimension number 6 out of the way, let's take a short trip down memory lane and give you a little bit of Hazeltest history. So the first use case for Hazeltest was in the context of experimenting with different thread pool sizes for one of Hazeltest's executor services, coincidentally the one that's responsible for responding to clients' getMap invocations. So I needed a very simple load creator that would simply execute a couple of getMap calls, measure and log their duration, and then sort of do a little bit of stuff to keep the CPU busy so that I could quickly iterate over the configuration for that particular thread pool, right? So, simple enough. So the first manifestation of this idea was the map Pokedex Runner. It didn't do a lot back then, really. It connected to the cluster, it ran getMap, it invoked getMap for a configurable number of maps, and printed its log duration and printed their duration on standard out in a way that the log analytics platform of the client that I was working for and am still working for, in fact, could easily process. And then, in order to keep the CPU busy, it executed a a batch of ingest operations, and then a batch of reads, and then a batch of delete operations, which came to be called later the batch test loop. It wasn't called this back then because there was no need to sort of distinguish that functionality from different functionalities, so there was no need yet to give it a name. But this functionality is basically what today's batch test loop incorporates, right? So that functionality was incredibly simple, incredibly basic, but it got the job done. For this particular use case that I had back then, it was sufficient. But it's sort of, due to its simplicity, the functionality had, its drawbacks kind of already built in. The first one of those drawbacks being that the number of items, that being low dimension 1, was adjustable only indirectly. What do I mean by that? Well, the Pokedex Runner is called the quote-unquote Pokedex Runner for a reason, right? It works on the entries of the first generation Pokedex. Well, the first generation Pokedex was the best, of course, which I happen to know because I played a lot of, the corresponding Pokemon games in school, as did you if your school was as boring as mine. And, that's it. It's 151 Pokemon, and that's what the Pokedex Runner ingests. Like, you can have it ingest more via the number of maps. So if you specify 1,000 maps, for example, if you tell a Pokedex Runner to spawn 1,000 maps, then you'll end up with 151,000 entries in Hazeltest. But that's only an indirect adjustment you can do. There is no direct, no knob or no property that lets you directly adjust the number of entries, right? And the item size, the size of each Pokemon, the size of each Pokedex entry, that being low dimension 2, was not adjustable at all. And that's a result of that runner working with the first generation Pokedex as well. That's a fixed data set where each item has a fixed size, right? In fact, you can go check it out in the code base of Hazeltest, because until today, that trimmed down version of the map Pokedex Runner that I used back then is still there, because the functionality is still the same as far as the Pokedex Runner is concerned. So low dimension 2 was not adjustable at all. The second drawback of the map Pokedex Runner is in combination with the, test loop functionality it had back then, which is today called the batch test loop. Let's be honest, a real-world client of Hazeltest wouldn't just ingest its entire data set and then read it back all at once and then delete some of them and then, rinse and repeat and always execute these 3 batches in a row over and over again. It was simple and sufficient for the use case I had back then, but the degree of realism of that kind of load generation simply wasn't very high. So the logical next step for the application was then to, add something that fixes or addresses the inherent and built-in drawbacks of the map Pokedex Runner, and that was really when the mapload runner was born. So the purpose of the mapload runner then is to address those drawbacks by introducing adjustability of load dimensions 1 and 2, that being the number of items and the item size respectively. As I mentioned, the Pokedex Runner works on a fixed dataset. In contrast to that, the load runner does not. So therefore, the number of items can be freely specified. You can specify 10 or 100 or 1,000 or 1 million or 1 billion if you feel particularly adventurous. And for the very same reason, the item size can be freely adjusted too. So if you wish to specify an item size of 1 GB, so be it. The application will do that for you, assuming that you've given it enough memory. So having adjustability for these 2 load dimensions is certainly nice, but it doesn't change anything about the degree of load generation realism, really, if the load runner is configured to work in combination with the batch test loop, right? It will, if you configure it to write 100 million entries, and if you configure each of those entries to have a size of 1 megabyte, for example, then, it's great to be able to do that, and will certainly, in terms of memory consumption, give the target Hazeltest clusters something to think about. But if you combine that with the batch test loop, it will be just, the same kind of ingest, read, delete kind of very simple logic that the load runner will rinse and repeat over and over again. And therefore, in order to address this load generation realism drawback, the boundary test loop was added in later development stages of Hazeltest. This boundary test loop does not only work for the load runner, so it's not exclusive to that. It works for the Pokedex Runner too. But we'll make usage examples later on in context with the load runner, of course, because, well, this video is about the load runner, right? Now, we talked about 2 load dimensions, right? The number of items and the item size. What about the others? We introduced 6 in total in scope of this video and in the context of the map load runner. So what about the other load dimensions? Well, the combination of load runner, the runner framework itself, as well as the adjustable number of Hazeltest instances, covers all the load dimensions except the 5th one, except the cluster health. There is a piece of functionality in Hazeltest called the Chaos Monkey, which, targets exactly like this 5th load dimension, but that's outside the scope of the load runner and therefore outside the scope of this video. Although when we take a look at the IDE in the next step, I will, very shortly mention it. And that's our bridge to the configuration of the map load runner. Short disclaimer before we actually make that jump into the IDE. You'll be presented with a YAML file, well, two YAML files, in fact. And you'll see in there that the map load runner has lots and lots of properties to be configured. What I'm not going to do is show you, give you an in-depth, sort of detailed explanation for every single one of them. Mostly because you'd need so much coffee that, you could send in your coffee machine for maintenance afterwards. And also, it wouldn't even be necessary. So, the reason being, the load runner shares most of its properties with the Pokedex Runner. And these properties are all very extensively documented in the documentation, in the default config.yaml file, which I'm going to show you in a minute. And what I'm going to do instead is, go for a far more efficient approach in terms of, your time, and show you only the most important properties. Those being, for the most part, the properties that set it apart from the Pokedex Runner. So with that little disclaimer out of the way, let's dive into the IDE. So here we are, and the aforementioned default config.yaml files is what you can see here on screen right now. In case you want to go check out the original file, it's in the codebase here. It's in the client directory, and as you can see, there's lots and lots of stuff in here. This is for the Chaos Monkey that I previously mentioned, and I did promise that I'd, mention very shortly that, this actor targets load dimension 5, the meta dimension being the cluster health. So this is the member killer monkey. So it's intuitively clear, in my opinion, judging by the naming, what this thing does. That's right, it kills Hazelcast members. And, well, yeah, that's the only Chaos Monkey available as of today. And, yeah, that's about all the stuff I want to say about it, because we're here for the map load runner. So, state cleaners, collapse that, Q tests, collapse that. This is all just to show you there's, lots of documentation in here. So if you want to go check out anything about the properties, the default config.yaml file is the place to go. In here, you'll also find a map tests key, which has, as you will discover, 2 subkeys called Pokedex and Load. And if you now guessed that those subkeys correspond to the Pokedex Runner and the Load Runner respectively, you'd be correct. Fireworks! So, here, you will find the aforementioned documentation on all the properties that, you can use to configure the Pokedex Runner, and the properties that, the load runner really has in common with the Pokedex Runner. And for those properties that it does not have in common with the Pokedex Runner, there's documentation down here on the level of the load runner, right? And it's these properties that we'll go through now, but, just so you know, in case you want to read it up, you can do so here in the default config.yaml file. I'll link to that file in the video description below. Let's head over to the values.yaml file. that's the second YAML file I want to show you. Why do we need another one? Well, because of this property, replica count 1. This property is not present in the default config.yaml. Why not? Well, the default config.yaml is the default configuration file for the application itself, whereas the values.yaml file corresponds to or refers to the Hazeltest helm chart. So this property actually defines how many instances of Hazeltest will be launched. So obviously, this property acts on load dimension 4, the number of clients. And it also acts on load dimension number 3, that being the number of data structures, when you combine this setting with appendClientIdToMapName true, and that's a setting that we'll explore in just a minute. So let's move down here to the load runner configuration, and the first property that I want to talk about is numMaps. I'll now go on a little rant about how hard it is to actually name things properly using the numMaps property as an example. Don't worry, I'll put the meta information on YouTube so you can actually, skip from section to section. So if in case you want to, just skip to the next section, that's totally cool. No hard feelings. You don't have to listen to my rant. And if you want to skip ahead, please do so now. Right. So, for everyone who's still here and, attentively listening and watching, thank you. I appreciate that very much. Right, the numMaps property. Well, when I first started working in IT, I quickly got introduced, as you were probably when you work in, the area, the general area of IT, got first introduced to that, the eternal idiom, let's say, or the internal proverb of there are only two things hard in computer science: cache invalidation and naming things. Or you may have heard some version thereof, but you probably know what I mean. And me, being young and stupid and naive, thought, well, cache invalidation being hard, that's kind of fair enough because, common sense dictates, and what I learned in my computer science studies dictates that, or suggests at least, that cache invalidation can be kind of hard, But naming things? Come on, how hard can it be? I bet that I will always find good names, good self-explanatory and totally intuitive names for the stuff I have to name. Yeah. That was many years ago, many moons ago, and, well, I'm still pretty young and probably in some aspects still pretty naive. But I learned a couple of things along the way, and one of those things was that naming things properly is actually really, really hard. And the numMaps property is one of the examples for this, okay? So, hear me out. numMaps 10. When you read this, what do you think? What do you think this property does? Well, it probably configures the number of maps to be 10, right? Yeah, that's correct. But not in all the cases. If you specify the appendMapIndexToMapName property to be false, for example, then the go routines that this thing over here, the numMaps property, actually spawns in the background, all write to the same map, because now they do not append their map index or their own index to the map name anymore. So now, if you let this run, the name of the map that will be, acted on by all the map go routines will be, in the case of the load runner, ht, that's, the prefix down here, ht underscore load. And the load bit is something that you cannot configure. That's something that's hard-coded in the load runner itself. So why didn't I call it, something else? Why is it still called maps if it's, obviously not the number of maps in all the cases? And this is where it gets, this is where the chain sort of starts, because the most precise name for this property would probably be numMap go routines, because that's what it really does. It configures the number of map go routines that, given, other pieces of configuration, will then translate or correspond to a certain number of maps, 10 in this case. But then, there's two problems with this. The first one is that you expose a detail about the programming language to the user. You tell the user, well, I'm using a programming language called Golang, and there's a thing called GoRoutine in this programming language, right? That's something that, like, the user, even if the user is a Golang programmer and knows what a GoRoutine is, the user shouldn't be bothered and probably won't bother about, implementation details like this one. So, and the second thing is, it not only, like, exposes details about the programming language being used, but also about the programming model that's being used. That being that there's stuff being executed concurrently on GoRoutines in this case. That's an implementation detail that the user shouldn't have to care about, right? So for these two reasons, nummap GoRoutines, although it is the most precise name, wouldn't be a good name, because it would expose too many details. So you could say, well, okay, fair enough. Let's ditch the programming language from the context, right? Let's just call it nummap threads, because a GoRoutine is simply only, the Golang flavor of what's called a thread in other programming languages, a lightweight thread, so to speak. Okay, fine. You removed successfully the context to the programming language and the context to the GoRoutine, but still there is this detail about the programming model that's used, right? You tell the user, well, there's some kind of threading going on, stuff is executed concurrently. And again, that's just a detail that, like, the level of detail that's exposed to the user is still too high, right? This kind of complexity should be abstracted away from the user, right? So nummap threads isn't a good idea either for that reason. Now, in the next step, you could say, okay, let's remove the detail of the programming model being used too, right? And call it, very generically, something like numMap actors or something. Okay, congratulations, you successfully removed the context to the programming language, to a certain programming language, Golang in this case, and B, the context of the programming model being used. But still, that's, what on earth is a map actor, and how does that correspond to the, number of maps that the user will see or create on the Hazeltest cluster using the load runner thus configured. So numMap actors hides the details, but it's still very unintuitive, and you'd sort of have to read the documentation or even, fire up the load runner and see what it does to understand how this property behaves. So for this reason, and the other, the previous two suggestions had the same problem. In fact, it's if you specify the number of, map GoRoutines or number of map threads or even the number of map actors, what all these three suggestions have or those three names rather, have in common is that they are really unintuitive. Like, it's not clear immediately what these properties do and how many maps you'll actually get out of them. So, I started with numMaps as a name for this property, and then, started thinking, and, one thing led to another, and then I ended up with the same name, numMaps. Perhaps I'm so, down that rabbit hole of thinking about that name that I miss the totally obvious solution. Or maybe I'm just being an idiot. That's totally possible too. So in case an alternative and really good name for the numMaps property, please do let me know in the video section below. I'd love to hear about it, okay? And if it's a good name, I'll implement it. But so far, numMaps is the best name for this property that I could come up with. Because if you have the default setting, then numMaps 10 actually equals to 10 maps, actually equals 10 maps and will actually correspond to 10 maps on the target Hazeltest cluster, right? So if you're a user and you fire it up, then, and you use the default configuration, then that will give you what you will expect based on that name. And it's only when you set this to false that, this will become a little questionable and unintuitive. But then if you tinker with the defaults, then you're at a stage of using the program where you'll probably feel more comfortable reading the documentation, or even a little bit of source code if you're a Golang programmer and interested in the technical intricacies. So therefore, again, numMaps is the best name I could come up with. Right. Rant end. So note to self, put in end of rant section in the meta information. So yeah. And if you skipped ahead, this is probably where you will have skipped to. I'm done with my rant, and we can now move on with the meaning of the numMaps property. And if you listen to the rant, then, well, you'll be at a slight advantage, because you will now know that the number of maps corresponds to, well, the numMaps properties corresponds to the number of maps in the target Hazeltest cluster. So that's load dimension 3, but only if you specify append map and map index to map name to be true. So hence there is this little comment that I inserted here, that this also corresponds to load dimension 3. If you specify, so for those who skipped ahead and didn't watch my little rant there about how hard it is to name things properly and how I'm haven't found an ideal name for this yet, if you specify this to be false, the name of the maps will be, only one map will be created, being HD underscore load. Yeah, that's it. HD underscore load, and that's it. If you specify true, then you'll end up with 10 maps in total, being called HD underscore load dash 0 through 9. So you'll actually end up with 10 maps. So that's the number of numMaps property. The next one that I'd like to introduce you to is the numEntriesPerMap. And this is obviously something that the load runner doesn't have in common with the Pokedex Runner, right? The Pokedex Runner is strictly limited to 151 elements per individual map actor map, right? So in this case, the default that I put into the values.yaml file. So if you install the hemshot like this, the map load runner will spawn 10,000 entries per map. So this corresponds to load dimension 1, obviously, being the number of items. So onward to the next one. What this does is it simply, as I briefly mentioned, makes the map coroutines that will be spawned X times if you specify this, to append their map index to the map name. So this also, adjusts sort of the number of maps that you will get, but not the number of map coroutines or the number of map actors that you will get on the target map or maps, right? So, and this property, appendClientIdToMapName, this is what I mentioned before, very briefly though, up here, right? If you specify this to be true, then each Hazeltest instance, each Hazeltest instance always receives its own unique ID. And if you specify appendClientIdToMapName to be true, then each map actor go-routine will append the map, the Hazeltest client ID to each of the map names that it acts on, right? So this property is a fantastic way to spawn thousands of maps really, really quickly. For example, if you specify the replica count to be, 100, and you go down here and specify, numMaps to be 10, that's not a lot of maps for the load runner, right? And specify this to be true, then in combination with those 100 maps, that will give you 1,000 maps, right? And, it goes on. If you specify like 100 maps, this will give you 10,000 maps in total. Just like that. And that's pretty cool, in my opinion. So that's, that adjusts very, very heavily the number of data structures on the target Hazeltest cluster being load dimension 3. The next property, or, set of properties rather, that I'd like to introduce you to is the payload properties, which obviously correspond to, the item size, that being load dimension 2. And this is also obviously a property that the Pokedex Runner does not have. Short note here, the previous two Hazeltest videos worked with an older version of Hazeltest. Well, it was the most current version back then. It was version 0.10.1, I think. Well, today we got version 0.16.1, so lots of stuff was added to Hazeltest. Much new functionality was added. And one of the new pieces of functionality is that I introduced variable payload sizes. Back then, if you watch the old videos, there's a property, I think it's called payload size bytes. And if you specify this, to be 100, for example, so let me just adjust this. So payload size 100. Then the old configuration, like this, is semantically equivalent to this, what you have today. So today, this property does not exist anymore. Instead, today we have fixed size payloads, and we also have the option to specify variable size payloads. So let me quickly re-enable variable size properties. So what the fixed size property does is, I think, pretty clear. It creates a payload of size. It uses payloads of size X, whatever you specified here. This, for example, again, if you set this to true, this would give you payload sizes of 100 bytes. So each item that you write to target Hazelcast map will be 100 bytes large. And that's perfectly sufficient for simple use cases. But again, it's not very realistic because usually, in a production Hazelcast cluster, you'll see hundreds or even thousands of clients. And not all of them will write, items having the same sizes, right? So to cover that kind of scenario, there is the variable size property. And it's also a property, in fact, I introduced it specifically to test one of the memory managers being available with the with Hazelcast's HD or high density memory store. If you don't use Hazelcast Enterprise, don't bother with that, because it's an enterprise only feature, but it's a really cool feature. So, I'd use Hazelcast Enterprise for this alone because it stores memory off heap. And things that are loaded off the heap are always great for the reason alone that they cannot cause an out of memory error on the heap. So that's a really good plus right there. And one of the memory managers available for the native memory or high density memory store in Hazelcast is the pooled memory allocator, which is actually the default. And it's the pooled memory allocator works great for fixed sizes, but it struggles a little bit with variable sizes. So I introduced the variable size feature in order to sort of test whether our particular configuration of the pooled memory allocator would be able to handle, variable size payloads in terms of the boundaries that our real world clients, use on our Hazelcast clusters. So in this case, these are not the actual values. These are just example values. Low boundary bytes is 1,000 bytes here, and upper boundary bytes is 10,000. And what this does is it simply picks upon, starting up, it picks a random number within this interval, right? So for example, 6,219. And it will use that size, that number, for 100 times for successful writes. So it will reevaluate a new size after 100 successful write actions. So if a write action was not successful, then it will, not increase that counter internally and will not redraw like that number that it will use for, creating the payload. Of course, you could also specify 1 here. That would mean that after every write it has done, the load runner will reevaluate or, draw a new number from within that range and then create exactly 1 payload of that size, write that to the target Hazelcast cluster, and in case that write was successful, in the next round of writing, will, immediately draw yet another number. I specified this to be 100 because, I For no particular reason, actually. I chose this default. I think it's the default. Let me actually check if that's the default. Yeah, that's the default. Yeah. So in here in the default config.yaml file, there is also, you know, that documentation in here. So in case you want to read up on it, you know, feel free to have a go. Right. The remaining properties that I would like to show you are all sleep properties, and they correspond to load dimension 6, because with sleeps you can indirectly influence the number of operations per second that the load runner executes. Now, this isn't entirely optimal because it's only indirect, right? It would be far more convenient on the user side to simply, you know, specify something like, give me 1200 sets per second and 600 gets per second and, I don't know, 700 removes or something. But maybe that's something I'll implement in the future. But the problem here is that, you know, the number of operations per second depends on so many variables. So the feature would probably have like very limited scope. And so I'm not entirely sure if it would actually yield that much additional value over what's there currently. Let's do a short example of why I think sleeps are actually pretty nice, beyond, you know, the ability to influence the operations per second indirectly. So let's specify, this is the between runs sleep. So in case of the batch test loop, one set of batches like ingest, read, and delete is one run. It's a little bit different for the boundary test loop, but there is a similar idea of, you know, that's one run and that's one set of actions that I've done. So, for example, if you have a monitoring system sitting on top of your Hazeltest clusters, which you probably have, because, you know, Hazeltest members expose a lot of really useful Prometheus metrics, for example, if so configured. And it's really interesting to sort of see how those metrics change and the Hazeltest members behave when under load, right? So if you wanted to see in those metrics when a run starts and when a run ends, you could, for example, you know, disable randomness here to give it like a static amount of time that it sleeps after performing each run, or, you know, between the runs, i.e. after ending a run and before starting the next one. So for example, we could make it sleep for 5 minutes by specifying a sleep of 300,000 milliseconds. Now that's a lot of zeros here, but still it gets the job done. It will make the map load runner sleep for 5 minutes. And so you'll be able to clearly tell in the metrics, you know, this is when a run started and this is when it ended. So you can, you know, put that in a you know, a dashboard or a screenshot or something, and evaluate how the Hazeltest cluster behaved in one run. And I think that's really useful information. For now, I'm gonna revert my configuration here. So the remaining sleeps refer to the batch test loop. Okay, so this sleep block, or the boundary test loop. But in order to understand how these sleeps work, you'd have to have very detailed knowledge about how these test loop types work, right? So, and this is beyond the scope of today's video. So let's just say for the time being that you can use those sleeps to influence load dimension 6, that being the operations per second. So you can, you know, obviously reduce the sleep time if you wish to have a higher number of operations per second, and vice versa. So that's the most important properties for the map load runner. Let's do a very short recap because, you know, it was quite a lot of information to digest. So let's go over it very, very briefly. So up here, you have the replica count property. This configures load dimension 4, or this acts on load dimension 4 being the number of clients, and also on load dimension 3 the number of data structures if you have configured the appendClientIdToMapName property to be true. Let's scroll down to the load runner. We have the numMaps property, which was very difficult to name and in fact remains difficult to name. This acts on load dimension number 3, the number of data structures, That is, if you have specified appendMapIndexToMapName to be true. Hence down here the comment, that this acts on load dimension 3 as well. Then we have the number of entries per map. This obviously, specifies the number of entries that the load runner will write and therefore acts on load dimension 1. Then we have appendClientIdToMapName, this being again the property that in combination with the replica count acts on load dimension 3. And then going further down, we have the payload object and all the properties that come with it. This configures load dimension 2. And then down here we have a couple of sleeps and they act on load dimension 6, that being the operations per second. So now that we've learned about the most important configuration properties for the load runner, let's move on to 2 usage examples that I'd like to make. The first one is the load runner with the batch test loop, or in combination with the batch test loop, because despite, its limits in terms of, flexibility for how to create load or how to, model how load gets created on a target Hazeltest cluster, the batch test loop still has its usage, far beyond what I initially mentioned when, talking about the Pokedex Runner and the very first use case that, was really very simple indeed. So in the first video about Hazeltest, I talked a lot about, release candidates that describe Hazeltest clusters and how to, assert their production fitness before rolling them out to production, ideally. So, and the batch test loop has a very, very important, purpose in this context, right? If you're in an early stage of testing a release candidate, then the realism of the load generation is actually far less important than quick feedback on how fit this release candidate is for production, right? So the idea is that, in scope of your CI/CD pipeline, for example, you made a change, for example, to the memory configuration of your Hazeltest cluster in, say, a Helm chart, right? You throw the Helm chart onto a Kubernetes or OpenShift cluster, and now you need to know quickly if that load configuration broke anything or if it works. So you need quick feedback. You need a quick load test that ingests as much data as possible within a short amount of time as possible. So ideally, that test should run minutes at most. 2 or 3 minutes don't sound like a lot, but if you want to do 10 to 20 iterations on your release candidate a day, then, those 2 or 3 minutes turn into hours really quickly. And most importantly, the longer you have to wait, the more likely it is that the waiting time pulls you out of that flow state that you may have worked yourself into, right? So that's also, that psychological aspect is also very important. So the test has to be short, yet effective. So the load runner in combination with the batch test loop is, as it turns out, a perfect fit for that. Because the load runner brings adjustability of the number of items, that is, load dimension 1, and their size, that is, load dimension 2. And the batch test loop brings the capability to quickly ingest, this desired number of items. So, for example, you can specify the number of items to be 1 million, and their size, their individual size, to be 5 megabytes or something, something pretty large, or even 10 or 20 or 30 megabytes if you give that, the Hazeltest instance that will create that kind of load enough memory. That memory is really the limit for what you can do. That means that you can bring the target Hazeltest cluster under test to its memory capacity really, really quickly, and thus get very, very quick feedback on the on the fitness of the release candidate that spawned or described this Hazeltest cluster, right? So you get quick feedback. Ideally, you remain the flow in that flow state, right? And so the idea of this combination of functionality is that you can maximize the number of iterations that you can do on a release candidate within a given time frame. And although the boundary test loop is, much more advanced and gives you more flexibility in terms of modeling load according to what's there in production. It uses more CPU, it's more difficult to configure, and it's slower. So you can achieve a much higher number of sets per second, for example, if you use the batch test loop. So for ingesting stuff quickly into your Hazeltest cluster, the batch test loop in combination with the load runner, or vice versa, actually, the load runner in combination with the batch test loop, is actually a really, really good solution. The second example I'd like to make is about, set boundary test loop, because that was obvious, wasn't it? So once your release candidate has passed that initial fitness threshold imposed by that super quick smoke test thing that you ran with the batch test loop, more testing is required, obviously, and the further you go in your iteration cycles, the more extensive that testing has to be in order to, really find out whether there's any issues with your configuration. For example, testing something like van replication will take more than only 2 or 3 minutes, because sometimes issues with van replication, for example, the van replication queues being too large and then, using too much memory on the heap and then thus crashing the JVM, that kind of stuff typically doesn't manifest after 2 minutes unless you really go crazy with the payload sizes that you put on the queues. So in this later stage of testing, the realism of load generation becomes, so priorities kind of shift, right? Speed of testing becomes less important, but the degree of realism becomes more and more important. So the idea of the boundary test loop, therefore, is that you take a look at your production clusters in terms of those, 6 right now load dimensions, and measure the load in terms of those 6 load dimensions, and then sort of model that load in a test environment, or sort of recreate that load in a test environment using the combination of load runner plus boundary test loop. And this combination is a good fit. It's not perfect yet, because the modeling because you typically need more than one Hazeltest installation to get close to the load that your Hazeltest clusters are exposed to in production. Typically, when I take a look at our production clusters, there's the Pareto rule, right? Only a very small number of data structures will accumulate the majority of the load. Sometimes it's 20% of the maps that will accumulate 80% of the load. Sometimes it's 15, 85, 10, 90, whatever, something along the lines of that. And so I use one Hazeltest release, speaking in terms of one Helm release, to model this load, and then I look at sort of the rest and see what that does, and use another Helm release, or install another Helm release rather, to cover that kind of load too, right? And that's possible, and that's certainly doable, but it's not very convenient, because ideally, that kind of modeling functionality would be a bit more, a bit easier to use, really. So, there is likely to be some movement on that front in the future. But again, it works, so it's a good fit, in my opinion. So the goal here is to simulate production load in scope of a load test that runs, minutes to all the way up to days. It could run, a couple of hours. It could run throughout the night. That's typically what I do. I start a load test and then go off, do something else, such as, sleep, and then log back in the morning and see what's happened. But it could also run multiple days, right? And the boundary test loop is, it simulates the sort of ups and downs that you typically see in the maps of a production Hazeltest cluster throughout the day. Only it does it a lot faster. So typically, the Hazeltest clusters of my clients see one maximum a day, obviously, and usage numbers are slowly climbing and then slowly declining. The boundary test loop does precisely this, only, again, a lot faster, because you don't want to wait 1 day for that maximum of, for example, the number of items in your maps to be reached. ideally that's a bit faster, right? So the map load runner, the load runner in combination with the boundary test loop will sort of, go like this very, very quickly. Or, as quickly as you want it to, really, and as quickly as the CPU that you've given it will permit it. And consequently, the load generated by the boundary test loop is closer to that created by real-world clients, but it's not identical yet. So if you want to make it identical, or get close to, being equal, then, it takes a lot of modeling, and it takes many Hazeltest instances and many different speak in terms of Helm, many Helm releases for Hazeltest to get close to that identity or equality. And that's that's a lengthy process. So again, there's probably some movement along simplification of this in the future for the the boundary test loop, or even a new test loop. Who knows? So that's it for this video, ladies and gentlemen. That was part 1 of the Let There Be Load series. There will be a part 2 and a part 3, in which we will take a closer look at the batch test loop and the boundary test loop, because those played important roles today, but we didn't actually get our hands dirty with them, although the usage examples that we talked about sort of already hint at what we're going to do in scope of part 2 and part 3 respectively. And well, until then, and happy Hazeltest cluster testing, everybody.